This is a follow-up video on how to lay out balusters with the Construction Master Calculator. If we have an opening between two newel posts that is 80 inches, then we would have a baluster of, in this case, we'll say 1.25 inches. To get even layouts, we would take 80 inches. To that, we would add one baluster width plus 1 inch 3/4. Gives us 81 3/4 inches. We want to know a unit run, and the unit run would be one baluster plus one opening. So we're going to look for an ideal of a 4-inch opening plus our 1 3/4 baluster. So we're going to divide that by 5 3/4, 4 inches plus the 1 3/4. Divide 5 inch 3/4, and we get 14.2. So we'll move up to the next larger number. In this case, we're going to go to 15. We're actually going to use 14 balusters because we added one in. We're going to use 15 to determine our spacing. So we're going to multiply back by 5 inch 3/4 to get back to our original 81 3/4. We're now going to divide that by 15. And we get 5 7/16 on the display. It's actually kept as a fraction. We're going to add that as memory plus. We can now take that number, and if we add it to itself, where we hit plus equals, and we keep hitting equals, it will lay out to 81 3/4 inches. If, however, we want, and that's from the face, leading face to leading face. If what we want instead is to know where the center line is, we need to move the array of balusters, where we mark it, instead of at the face, back half a baluster width to the center line. So we'll hit 0. We still have the number in our memory. If we hit memory, our recall memory plus, we get our 5 inch 7/16. So we're going to subtract half the width of one baluster to move the whole array back to the center line markings. We can take 1 inch 3/4, divide by 2, and we'll get 7/8. So we have 7/8. So we can hit a minus 7/8 of an inch plus recall memory equals. So our first one, now instead of getting laid out at 5 7/16, we'll get laid out at 4 9/16. And when we hit equals again, we'll get 10 inch, and it'll work all the way down the array, marking off the center lines. So it's very fast, very accurate. It doesn't round to the nearest 16th. It only displays the nearest 16th. So you'll find that it'll vary 16th and 1/8 on the display, but your unit spacing will be identical. Let's look at another situation where instead of having perfectly square newel posts and balusters, because we're laying everything else that we have off of the base, off near the floor, where all of it's square, a lot of newels tend to start square and then have turnings where they taper down. The same thing happens with the newel post. So if we simply go off of the square sections, we may find that higher up we exceed our 4-inch spacing. So we're going to want to look at a way where we can move the first baluster and the last baluster closer to the newel post, yet still have an equal spacing on the main run. So we'll clear everything out of the calculator. So we now have nothing in it. we'll go back to our 80 inches. This time we're going to hold a baluster up to the newel post. One for aesthetic reasons, to see how we like the look of it. And the other is to find out where it tapers down so that we don't exceed our 4-inch spacing close to the rail. So let's assume for a moment that we've moved this thing back and forth and we're checking our center line here. We're not going off the face. So we hold it up and we look and we say, okay, we like this spacing. We know that we don't have a 4-inch rule problem. We're assuming we've got over the post system. It's a pin top newel post and say pin top balusters. Let's say our center line spacing to face of newel is 3.5 inches. We would like to have the first one and the last one laid out 3.5 inches from the newel, and all the rest of them to have a greater spacing. So if we take our 80 inch, enter it in, subtract our 3.5 inches from first one, so minus 3 inch 1/2 equals, we get between the first and the last one 73 inches. If we divide that 73 inches by 5 inch 3/4, just like before, we get 12.69. We'll round up to 13. So 73 inch divide 13 equals, and the display unit number on this is 5 5/8. We're going to hit memory plus. Now we want to start off our first one at 3 inch 1/2, and then we're going to hit plus, recall memory plus equals. So our first one, we know our center line spacing is going to be 3.5 inches. Our next one will be 9 1/8, and we'll hit equals and walk all the way down the array, 14 3/4. And we can work our way all the way down to where we get to our 73 inches. We got 70, so we work our way down the line. We got 70 7/8, 76 1/2. So what we're looking at now is the first one is 3.5 in the first one. We got all the way down to our last one, which is 76.5. If we add 3.5 inches, we're at our 80 inch. So now we've got the first one and the last one, both 3.5 inches from the newel post at the center line. But if we look at our spacing on the rest of the run, we'll take 14 inch 3/4 minus 9 inch 1/, whoops, let's start over. 14 inch 3/4 minus 9 inch 1/8. We get 5 5/8. Subtract out one baluster width, because we got half of one baluster, half the other baluster. That gives us a total of one baluster, minus 1 inch 3/4. Our spacing between the newel posts on the main run is 3 7/8. Here at the end, where it's next to the newel post, we have 3 inch half minus half our width, minus 7/8. So the spacing here between the first newel or between the newel and the first baluster is 2 5/8, and the rest of them are 3 7/8. So all the common ones will be 3 7/8, and the last two will be 2 5/8 based on our determination of what we want it to look like. And so that makes it a pretty easy way, a quick way to lay it out.